Hey guys, Vladimir here, and as you know, I love to design and 3D print my own creations. But where I really get excited is when I get to combine 3D printing with electronics. So for my next project, I decided I was going to use Adafruit's new board, the Circuit Playground. And the main reason I chose to go with this board is that it comes with LEDs already built in. So there's 10 neopixels that you can program to be any color you want. And this turns out to be very convenient for what I need to do with it. So in addition to the 10 neopixels, there's actually a motion sensor, a temperature sensor, a light sensor, a sound sensor, a mini speaker, 2 push buttons, a slide switch, and 8 alligator clip I/O pins. So really a lot going on in this small package. So definitely check this out if you're into this kind of stuff. But I digress. Let's get back to my project and what today's 3D print is going to be about. As I mentioned, the Circuit Playground has these alligator clip friendly I/O pins that make it really convenient for rapid prototyping. For example, here's a project where I have the Circuit Playground, a servo motor, and a push button, and programmed it so that when I push the button, the LEDs turn green and the motor spins. When I release the button, the servo motor stops and the LEDs turn red. So here's my dilemma. Basically, I want to be able to take my completed project to maker fairs and other events without having to worry about the wires coming apart or having to assemble it on site. So what I want is a more sturdy connection without having to solder the pins. Here's the solution I came up with. I used Fusion 360 to design this Circuit Playground screw terminal block, which allowed me to take my project from something that looked like this to something that looks like this. Sturdier connections and a lot tidier. After 3D printing my design, I went ahead and applied a little bit of CA glue and glued in some M3 nuts. Now you want to be careful with the glue there, only apply just a little bit so you're not getting any in the threads. And as you saw there, I only glued the 2 opposite corners, and the rest of these I went ahead and press fit them in. Then take your Circuit Playground, align it to the board, and go ahead and screw in those M3 screws. In my case here, I only screwed the ones that I glued in, which was the VBAT and ground. Next, take your jumper wire and just curve it so you have a little hook. Attach it to your screw terminals and simply screw them in, and attach the other end to your breadboard or whatever it is you're hooking it up to. Once again, here is our original circuitry, and here is our new and improved version with our Circuit Playground screw terminal block. Okay, let's go ahead and jump into Fusion 360, where I'll show you step by step how to make your own Circuit Playground screw terminal block. And if you like what you see, make sure to check out my website, desktopmakes.com, where I have a bunch of courses on teaching how to design for 3D printing with Fusion 360. We'll start off by first visiting Adafruit's website to grab an image of our Circuit Playground. So go ahead and launch your browser, type adafruit.com and click on the search bar here and just start typing Circuit Playground. You can see it'll pop right up, so you can click on that image and then just scroll down. We're going to want to find a link, which is schematics and data sheets. So go ahead and click on that and then scroll down again until you see this image, and that's what we're after. So go ahead and right click and save this image to your computer. So once you go ahead and click Save Image As, you can now go back to Fusion, go on Insert Attach Canvas, and let's first go ahead and note the dialog box that pops up. So we're going to choose our face that we want to put that on. In this case, it's going to be this XY plane, or that green-red plane. So click on that and then click on Select Image. In my case, it downloaded to my Downloads folder, and I'm going to click on it, and you can see it brought it right in. So a couple more things we're going to do. One is to bring the opacity down to about 30 something, and that just allows us to be able to see through our canvas when we start sketching, and then make sure to click on Display Through. Click OK, and you can see our canvas is right in place, and then just click on the top view here of our view cube, and we'll rotate this so we are looking straight up down on it. Now, the nice thing about this is we can see that we have units right here. So there are a few things we're going to do, or two things actually, before we start sketching. And that's going to be one, to calibrate this, and two, to center it. So to calibrate it, we'll right click and expand canvases, click on our circuit playground image here, and choose calibrate. Now, the beautiful thing with Fusion is, although we're working in millimeters and this is in inches, we don't have to worry about switching back and forth. We can simply go ahead and click on the two endpoints here between our measurements, and as long as we type what unit we want it in, Fusion will make that conversion for us. So I'm gonna type 2 and just make sure I type inch. If you don't type inch, it's gonna think you want to work under your default units, which is millimeters. So just go ahead and type inch after 2, and this will be calibrated to 2 inches. Alright, let's go ahead and center this now. So we'll toggle our origin on so we see it here, and then we're gonna right click on our canvas and go to edit canvas. We'll get our manipulator that allows us to move the canvas around. And what we're going to want to do is grab this so that the center, which is a little bit difficult to see, but you can see it between these 4 yellow brackets here, you have this little cross in the middle. Grab that and move it so that it's right in the center of our origin there. So just go ahead and eyeball that and make sure you're zoomed in so you have a clear view, and then click OK. Alright, so we're centered, we're calibrated, so we're ready to begin sketching. So we'll go ahead and click on Create Sketch on our toolbar, and we'll choose our XY plane here. And we're going to draw a circle from our origin. So we'll hit C for circle. We'll go to our origin and go out. We know that diameter is the 2 inches, so we'll go ahead and type that in again, 2 inch. Make sure to spell out inch and hit enter. And let's go ahead and get rid of that canvas for now. So we'll toggle that light bulb, and we have our 2 inch circle, or as you can see, it's 50.8 millimeters. Okay, so that's our basically our outline of our circuit playground. So what we're going to want to do when we 3D print this is we want it to be actually a little bit bigger than that, so we can have a little wiggle room there, and we're not, trying to really squeeze that in there. So we'll do an offset. So we'll go to Sketch, Offset, and we'll click on that perimeter there, and we'll give it an offset of 0.5 millimeters. And then we're going to want to create a little border, so we'll do another offset. So we'll right click and do repeat offset, choose that original perimeter, and this time we're going to do 1.3 from that. And what that did is it gave us this edge here, which is 0.8 millimeters. We can confirm that by inspecting and clicking on these two circles here, and we see that that's 0.8. And since I'm printing it with a 0.4 millimeter nozzle, that gives me a width that's 2 nozzle widths apart. So that works out. Next, I'm just going to click on that inner circle and hit X and make it a construction line. Okay, now I'm going to stop sketch, choose that inner circle, and extrude that up 7 millimeters to give me this cylinder. And I'm going to create a sketch on top of that face and bring in that canvas again. And I want to now go ahead and create these circles here, which correspond to my pins on the circuit playground. So let's hit C for circle again, and I'm just going to eyeball this in place. And what I'm going after is that green circle. So I'm just going to kind of get it there, eyeball it into the center, hit D for dimension. Let's dimension this out to 4 millimeters and zoom out, and now we're going to want to dimension this from our origin. So D again for dimension, click on the origin and click on our center circle. I'm going to make this vertical dimension of 20 millimeters, D again, and then this time I'm going to draw a horizontal, or put in a horizontal dimension. And so I want to click between those 2 points, and this time I'm going to do 11.5, and that's going to constrain that in place, so now I can't move this at all. So now that I have one circle in place, what we're going to do is create a circular pattern to make the rest of them. And to do that, we're going to note that we have 7 circles on one side and 7 on the other side. But the way we're going to approach this is to think about it a little bit differently. So notice that if that pattern was to continue, what really we're missing are the 2 circles that would have fallen in between the left and the right side. So 2 on the top and 2 on the bottom. So knowing that means we would have had 7 on one side, 7 on the other side, so 14. It would have been 15, 16, 17, 18 circles in total. So let's go ahead and make this with 18 circles. So we'll go to Sketch, go down to Circular Pattern, choose our circle, our center point. Go ahead and click on the origin and quantity. We're going to choose 18. But now we can actually go in and uncheck these circles that we don't really need. So by suppressing those, we'll get the exact pattern that we have there. So we'll click OK, and we can see that our circles match exactly what we have. So we can click Stop Sketch now. I don't need to see that canvas again, so we'll suppress it. E for Extrude, and we'll go ahead and select each one of these profiles. And we'll take that arrow, drop it down. We're going to go down -6 millimeters, which will leave us 1 millimeter of material on that bottom there. Make sure it's set to cut and click OK. Alright, now we're going to go back to that sketch. So go down to your timeline here and double click on that sketch. And next we're going to go ahead and make our insets for our hex nuts. So we're going to click on Create. Actually, we're going to go to Sketch, go down to Polygon, circumscribe polygon. We'll grab our origin of this original circle here, come out to draw a polygon, and then let's dimension this from this edge to this edge. We'll make this 5.5 millimeters. That's because I measured the hex nuts I'm using. It's 5.4. I'm going to make it just a little bit bigger, so at 5.5. So I'm just going to grab this and actually turn it a little bit this way, and then I'm going to draw a line from the center to the midpoint of this edge here. Notice we get that triangle there showing us that that's the midpoint. Grab that line and make it a construction line by hitting X, and then I'm going to grab a perpendicular constraint between that line and this edge, and that's going to snap that polygon so that it's now perpendicular to this line. Okay, we're going to stop sketch. Let's bring our sketch back in because it untoggled. And then we're going to hit E for extrude, grab that profile, bring it down. I'm going to do -2.6 millimeters. The thickness of the nut I'm actually using is 2.3. I just want to make sure that it's going to be completely inset in there. Okay, so now we're going to create another circular pattern, but this time we're actually going to do it in the modeling environment and not in the sketching environment. So we're going to go ahead and go to Create, Pattern, Circular Pattern. Pattern type is going to be Features, and we're going to select it from our timeline. So we'll select that last extrusion that we did. The axis, we'll just go ahead and choose that outer perimeter of our circle. Quantity is going to be 18. And again, we're going to do the same thing where we're just going to go ahead and suppress these top 2 and bottom 2 extrusions, and then click OK. And we can see that we have our 18 hex circular pattern. The nice thing about doing it in a modeling environment instead of back in the sketching environment is that you don't have to make a million selections. You do it once and then just create your circular pattern. Okay, so let's go back now to that sketch. We'll turn it on, that first sketch that we did. Remember, we created this outer rim here. So let's extrude that up. So we'll hit E for extrude, select just that outer profile there, bring it up, and I want it to go up 2 millimeters past our top here. So if you remember, that first extrusion was 7 millimeters, so this one we're going to go 9, and we're going to make sure it's set to join as the operation and click OK. Alright, so let's clean this up a bit by getting rid of the sketches here and getting rid of that origin. And there, we are almost there. A couple more things we need. Let's go ahead and make some little mounting brackets here on the side. So to do that, let's go ahead and turn it to this orientation here. And let's go back to that first sketch. So, because remember that first sketch is on this bottom plane here. So I'm going to click on that, C for circle. I'm just going to draw a circle somewhere here, make it 20 millimeters, hit enter. And I'm going to go ahead and constrain this. So I'm going to grab a horizontal / vertical constraint. Constrain that between the center of the circle and the origin here. And then I'm just going to hit escape and just drag this up until it snaps right to the outer edge. And go ahead and draw another circle here. I'll make this 4 millimeters. And again, I'll constrain this to the origin here. And I'm going to dimension this. D for dimension. I'm going to make this 5 millimeters from this top edge. Okay, now I'm going to hit stop sketch. Make sure I bring that sketch back into view. E for extrude. Grab that profile. Bring it up 2 millimeters. Hit enter. And then F for fillet. And I'm going to fillet this out. I'll fill it about 20 millimeters, give me a nice taper there. And instead of doing it on the other side, I'm just going to go ahead and create a mirror. So I'm going to go to create mirror. Pattern type is going to be features. Object, I'm going to select it from my timeline. In this case, I'm going to select both the extrusion and that fillet. Click on mirror plane, and I'm going to select this plane here, so that blue, red, or ZX plane. And you can see you'll see a preview of what that's going to look like. So just click OK. Let's untoggle sketches there, and we can see that that's looking good. The next thing I'm going to do, and the final thing, is to get rid of a bunch of the middle here, because it's really just going to be a wasted material, and it's just going to take longer to print. There's no reason we need to actually make or print the center part of this. So let's go back again to that first sketch. So here on the timeline, I'm going to go ahead and draw a circle. I'm going to make this, you know what, let's escape out of there. I don't want to do it on that sketch. Let's make it on the top sketch here. So double click on that, C for circle, make that 38, hit enter, stop sketch. Bring it into view by clicking our light bulb, select it, E for extrude, and then we'll bring this down. Distance will go all the way through, and then click OK, and there we go. So get rid of sketches here, and that's everything. So now we can go ahead and print this out, and we'll have a nice little holder for our circuit playground, which will serve as a nice terminal block. Alright, I hope you enjoyed that. If you did, don't forget to like and subscribe. Also, if this was a little too fast paced for you, or if you're looking for more in-depth tutorials on using Fusion 360, specifically for designing for 3D printing, check out my website, desktopmakes.com, where I have full courses on designing with Fusion 360. Alright guys, take care.